Now we'll talk about different states that a process can be into. Like we know that uh, when a process starts execution or the program starts execution and becomes a process, that process can be in either of the states. So if we talk about life cycle of a process, then initially it would be in creation phase where the process is being initialized. Then it start execution, that is running state. The process starts running. It can enter into waiting state, maybe called as blocked or sleeping. The process waiting for resources or some events like IO related aspects. It may be stopped, suspended because of some signal. Okay, it may enter into zombie state. Okay, the process finished its execution, but its status is not yet collected by the parent. And lastly, it can be in termination state, like the process terminates and resources are cleaned up after its status is collected. So when we write man PS, we can see that Unix or Linux has more process states like listed here, like D, I, R, S, T, so on. We'll try to see some of them further, like by writing the code. Fine. So let me say I have a program written. Say I'm executing this code. Fine. Now we'll open another terminal here and we'll try to see the status of the code. Correct. Grep a dot status. I'm into say state of this executable. Fine. So one may see here our a dot out is in S plus mode because it is waiting for an input. We have added there scanf. So if you see S means interruptible sleep, waiting for an event to complete. And with respect to the plus aspect, it is in the foreground process group. Correct. Now suppose if I apply a signal as control Z to send it in background. Correct. And if I check now the status, the process enters into T state. Fine. T state. Now, when it enters into T state, ultimately what happened here? Let us see. T is stopped by a job control signal because I press Control Z, I send that process into background mode. That's why it is showing me T. Correct? Here. Further, like if I see there is nothing called plus or any other thing added, so that means it is in background. So if I bring it back, say for example, here, if I go and if I write FG again, okay, to bring it in foreground mode. Now, if I apply again this grep a dot out, it will enter into S plus. So that is how like the process states can be seen. Now let us say like if I write say PS dash EJH and this output I want to transfer to say a file called P. So if I check P, sorry, yeah. So if I check P, contents of P file are these all. Output of that PS command is copied. Now let me write cat P greater than Q. Cat P greater than Q. So if I check now ls dash L, so you can see this P and Q is having same size. So let me write cat P greater than Q again. I'm again combining or concatenating contents of P and Q together. And so if I see now size is increased, correct? Fine. Let me do it one more time. Now I will change this order. I will write here cat q and p. So you can see the size changed. So let me write this again. Size changed. So we'll keep on doing this. Now I will reverse the order again so as to increase the size. So it's 73 plus 29 would be there for Q now. So Q size is changed. So we'll replace again this. We'll keep on doing this. So I want to show you like some state which would be applied over here. Okay, so what would be the process state for Q? Now, as the program is executed, like this cat command is executed in background, it would be difficult for us to check its state. But we will see like how exactly one can get it. Now I will again combine. So I will keep on doing this for some time. If I check that ls output, so now I will replace this Q P. Now P is double. So let me add this again. So this will become 28. So I will change this. I will try to create this file with big text, big size rather. So approximately more than 1 GB, say for example. So we'll write here P, we'll write here Q. Correct. Now again back. Now you will see that it is taking some time rather. Okay. But by the time we go and try to check it, it will terminate the execution. So it would be difficult for us to really check the status. Okay. Now we'll start seeing this output. Correct. So I will terminate this code which I executed earlier. So what we'll be doing is so ps dash aux and grep will check with cat. Fine. Now, if I try to see this, like you would be saying, the cat command that we applied is here, cat p. Correct? Because as we're searching for cat, that's why it is showing me this output. So it is entering into D. Correct? So if I now apply this, let us check one more time. So it took some time and you can see that it is entering into D state. So let it be. So let us see like what exactly this D is. So D state is uninterruptible sleep because it is working with IO. So it is taking input and redirecting that as an output. Like input is taken from file and concatenated with the other file. So if I do this again, because it is doing that IO part, so you can definitely see that that state is D plus. Plus is again background mode. And this is for that cat command that we applied. Correct. So if I do this again, I'm showing you this repeatedly to show you like how exactly the state can enter in the process can enter into D state. And as I stated earlier, D is what? D is meant for uninterruptible sleep, usually IO part. Correct. So the process must have completed. It is it has completed the execution. Correct. So if I go back and fire now this again, so D. So in between, like while it is working, it may initially it may be in R, then it converted it to D because now if I press Control Z here, you will see that the state is changed. So that state is now T. Correct. So from the life cycle perspective of a process, one can see that The process may enter into either of the state depending upon the process that it is carrying out or the program that it is executing, or maybe the contents or the instructions that are passed by us through the shell commands.